Everyone is talking about MCP. The Model Context Protocol is being called a game changer. AI agents, smarter than ever. Tools, more connected than before. But is it really the future or just the beginning? Hey everyone, welcome to AI Flexion. Today we're diving into an exciting tutorial on the Model Context Protocol to Extended Control Protocol, a game changer in how AI agents interact with the world. So let's get started. In the world of AI agents, tools are everything. Without them, LLM are just chatbots. Tools give models superpowers. Browse the web, write code, analyze PDF, automate workflows. Without tools, they are just talking in encyclopedia. Let's compare the LLM responses with and without tools. Let's take an example. Imagine asking an LLM, "What's the weather like in Delhi?" A basic LLM without any external tools can only provide a generic answer based on past data. It has no real-time access to current weather updates. To solve this, developers started integrating tools, like this weather APIs, into AI models. Now when a user asks the same question, the LLM decides to invoke a tool, the application calls the weather API, the latest weather data is fetched and returned to the LLM. The user receives real-time, accurate weather updates. Tools give models superpowers. Without tools, they are just talking in encyclopedia. That's where Anthropic's MCP, the Model Context Protocol, comes in. Before MCP, integrating tools with models was messy. Every vendor had their own interface. MCP changed that. It introduced a lightweight standard based on JSON RPC to make tools safe, structured, and predictable for AI models. Let's dive into the MCP, model, context, and protocol, three key components that powers this. First, the model is the AI brain, an LLM trained on vast datasets. However, it doesn't have real-time information on its own. That's where context comes in. Context is real-time, external data that enriches the AI's understanding, enabling more accurate responses. Lastly, we have the protocol, a set of defined rules that govern how the model interacts with the context and executes commands. Now let's explore MCP server features. Prompts. These are instructions provided to the LLM. In a client application, prompts can be triggered using / commands. For example, a command to fetch weather information guides the model to generate accurate responses. Resources. These include API schemas, file structures, or database schemas. For instance, here's a schema of a weather API response, defining the structure of the data. Tools. Tools are functions used by the model to fetch real-time context. They bridge the gap between AI and real-world information. In this way, MCP leverages the power of model, context, and protocol to build smarter AI systems, bringing real-time awareness to models. I spent weeks working hands-on with MCP, building local MCP servers, testing with Claude Desktop, debugging with logs, reading the open source code, even creating custom test scripts and diagrams. And here's what I found. MCP is a great beginning, but it's not the end. In this video, I'll break down how MCP works, where it shines, where it breaks, and what a better future looks like. A protocol I call XCP. Let's understand the MCP flow. At the core, MCP uses JSON RPC, a lightweight language-agnostic protocol, to coordinate tool invocation between a model and your plugin. The user submits a query in Claude Desktop, and the MCP server sends both the query and a list of available tools to the model. The LLM determines the necessary tool, prompting Claude Desktop to send a tool request to the MCP server. The server executes the tool and returns the result to Claude Desktop, which then forwards it to the LLM. Using this result, the LLM generates a final response, which is displayed to the user. So, is it perfect? Not quite. Let's talk about where MCP starts to show its limits. Before we talk about where MCP breaks, let's be clear. MCP still shines in a lot of places. Here are 5 real niche use cases where it works beautifully right now. Use case 1, GitHub bot. a plugin that fetches open pull requests, checks PR status, or even triggers CI jobs on a repo. You register your tool once. Claude calls it like a native function. Use case 2, company leave balance checker. Connect to your internal HR system and expose tools like get leave balance or apply for leave. These are atomic, safe, and return structured outputs. Perfect fit for MCP. Use case 3, file system plugin. Read a file, list directory contents, or even parse a markdown doc. It's perfect for desktop agents, documentation assistance, or local note search. Use case 4, weather forecast tool. Simple, reliable API proxy that returns human-readable data from no, open weather, etc. Zero need for workflows or retry logic. A great match for MCP use case 5, compliance policy advisor. Ask about labor laws, compare policies with country-state guidelines, and return a text response. Great for static advisory use cases that don't need streaming or chaining. So yes, MCP still has a strong place in the AI tools ecosystem. But once you go beyond these kinds of simple atomic tools, that's when the pain starts. Let's go through a quick tutorial to understand and have a walkthrough of the code for developing MCP server. So we would be building an MCP server that would be giving us a stock price as well as the latest information around that stock. So let's start with setting the development environment. Then we open the terminal and then create the directory for our project. Then we will just check into the directory. Then let's set up the virtual environment and then we will activate it. After that, we will install the dependencies. So these are the dependencies. And we would also need one more dependency, which is finance. This is the Yahoo Finance APIs, which we would be using. Then let's create the new file for the server. So let's open this in the VS Code. Okay, so we can see the folder structure. Let's open the main file and have we need to create the MCP server. Let's go to ChatGPT and I would show you how we can develop the server quickly. So let's type here using YFinance library, write Python code to create functions which would fetch the current price of stock using the symbol given, then another function to fetch the latest top 3 news for that company using the YFinance Yahoo Finance API, write Python docs for the methods, and let's send this. So we have the complete code now. We would just use it and paste it here. So it has given the proper docs as well as it's using the YFinance library to get the price and news. So let's go back and in the MCP docs, we would use this fast MCP import and create an object of this class. We would be naming it the stock market MCP server. Okay, so now let's go to the tool execution section and copy the MCP annotations and add it here. Also at the asynchronous keywords here before the function, and then let's initialize and run the server. Woohoo! Our server is ready. We can check it using this command, uv-run, and then the server file. So as we can see, this is succeeding. Now we just have to go to this desktop config file and update the configuration by setting the parent directory and the file for the server. Now let's open Claude Desktop after setting it. So yeah, we can see we have two MCP tools available. First tool is to get stock price, which would be getting the stock price based on the symbol, and others is to get top news. It would get the top 3 latest news based on the symbol given. So let's now ask the question, what is the price of TSLA and the news around it? So we need to allow the access. We are invoking the tools and we are getting the response from our tools. So we got the latest news as well as the stock price, which is $2.262, and the recent news we are getting. In this way, using this MCP server, we can fetch external context data and give that to our LLM by using this standardized protocol. Let's talk about where MCP starts to show its limits. Now that we've seen where MCP shines, let's talk about where it breaks. Because once you step outside atomic tools, real-world limitations start to appear. Limitation 1, transport lock-in. MCP currently only supports this TDIO transport. This means the client and the MCP server need to run on the same machine. There's no native support for remote or distributed tool servers using modern transports like gRPC or WebSocket. Sure, you can work around it by wrapping remote APIs inside local abstraction layers, but that's not clean protocol design. Limitation 2. Naive schema design. The current schema spec is extremely raw. There's no support for parameter-level validation, no required fields, enums, conditionals, rejects, or default values. The burden falls entirely on the app developer, which contradicts the vision of zero-trust, vibe-driven agent development. Limitation 3. No observability. There is no way to trace tools. For example, HTTP protocol provides the latency metrics, trace ID. Every request can be logged and monitored, but with MCP, there's no native way provided to measure latency, audit behavior, or debug production issues. A modern protocol should provide at least basic metrics, trace IDs, and structured error output, but MCP has none. Limitation 4. No role-based access or security layer. Tool-level access control? Not part of MCP. Even with HTTP, we can have basic authentication and token validations, but with MCP, there's no way to impose RBAC scopes or per-user permissions within the protocol itself. If you want that, you're on your own. Imagine it as a web server letting anyone access any tools, which is dangerous. Bonus limitation. No test harness support. There's no developer-first CLI, no MCP test, no validation tools, no mock runner. You have to script your own test harness for every plugin, which slows down iteration and onboarding. These aren't theoretical gaps. I've run into every single one of them while building real tools. That's why I started designing something better, a protocol built for scale, observability, and developer happiness. Introducing XCP, the Extended Context Protocol. So what do we do with these limitations? Should we keep hacking around them forever? Or is it time to rethink the foundation itself? Imagine a protocol that supports any transport, gRPC, WebSocket, serverless, a protocol that validates tool inputs at the schema level, that supports observability, RBAC, test harnessing, and even tool chaining. By design, a protocol built for the AI-first, zero-code future we're heading toward. I'm working on that vision right now. It's called XCP, the Extended Context Protocol. And in the next video, I'll show you what it looks like and how it could change how tools and agents interact forever. Subscribe to AI Flexion and follow the journey, because the future of AI tooling deserves better foundations. Don't forget to like, share, and hit the bell icon so you never miss an update. Thanks for watching, and I'll see you in the next one.